I want to show you like a really basic program. There's a really basic Python program, right? Like it is assigning a value to A. Now let's say we're trying to solve a problem where we're trying to add a lot of stuff together. One way of generalizing the idea of kind of summing things, and a perfectly reasonable way of writing a small program where I'm kind of trying to indicate that C is just the sum of A and B. That's a perfectly reasonable little program. No issues with that. It's legible. I'm working through stuff. In the formula sheet, maybe there's a formula that has that small formula in, no problem at all. Here's where my problem comes in, where I see there's two kind of ways of approaching a problem where the number of numbers gets bigger. One way, and so remember in general now, we're trying to solve this task of like, how do I add a couple of numbers together, right? One way is, in my mind, kind of a really bad way. But it is the way that I most commonly observe in student code right now. And that is to say, if I have 26 numbers, I'm just going to power through it. Right? I'm just going to keep going, and then at some point I'm going to have this formula, and it's like, okay? A lot of people are laughing, okay? But let me show you a piece of code that may look a little bit more familiar.
Yeah.
Okay, does that ring a bell? Okay, so why is it so funny in the first example but totally fine in the second one? What's the solution here? What's the solution to this general idea? When I start having more than one thing and I have this kind of pattern emerging where, okay, I'm going to do stuff and then I'm going to do, okay, so I'm going to do x is equal, okay, because here, this is where it gets really, really bad because remember there's a corresponding block of code over here, which, okay, I think I'm going to blow some people's mind now. I hope everybody knows that you can do this.
Oh, yeah.
Let me maybe do this. Okay, so even though it's actually, and even though I know very few people are doing it that way, okay, that's still wrong. Or let's say it's wrong-headed. And the problem here is that there's a pattern. And when there are patterns, it's probably best to let the computer handle things. And so in the case of just adding lots of numbers together, the kind of structure that we have to generalize this idea that I have a whole lot of numbers and I just want to kind of do things with all of those numbers, it would be much better if I rewrote this program to use a list, right? So it would be much better if I just said, let's do this. Okay, so that's doing the same thing, right? Multi-line editing, it's like really great. But all jokes about the multi-line editing aside, but it's actually part of it's part of the thing as well, right? Because like you're doing multiple things at one time. Learn how to do big things with small commands. The second cell is a better program than the first cell. Now, a lot of people are thinking that is wrong. I prefer the first program, because I'm not very good at programming, and the less syntax I use, the better the program. The more closely the syntax resembles just the normal stuff that I would write in my book, the less trouble I have understanding what is going on. Okay? So I want to point out that there are these two counteracting problems. There's the one problem where you want to get stuff done, but you don't actually want to learn how to program. That biases you towards very, very simple programs where you don't use the programming language's ability to magnify your ability. You use Control-C and Control-V. Okay? That's because you can't think of how to generalize. You can maybe understand that there should be maybe a generalization. You don't know how to do it. You know that copy and paste will guaranteed work. And all of you sitting in the class are diligent hard workers. And so most of you have the ability to just like power through it. Like, okay, you want me to do 26 of these? Just give me a moment. You know, I'll just work through it. Like, and like I will make slow and consistent progress. When I'm halfway through, I'll know I'm halfway through. When I'm done, I know I'm done. Programming feels like throwing dice, right? Like I know I could write a program, but maybe I'll be here for 5 hours and the program will still not run. And I will have nothing done. Versus like if I just powered through it, like I'll be 95% done after 5 hours. The problem is you remember too well when you were very bad at programming. And you project too poorly how much gain you get from these generalization methods. Right? So you remember that time when you were just learning how to program when you spent 5 hours trying to figure out what was wrong. And you don't project. You don't say, oh, if I do this the right way with programming structures, I benefit in a compound interest way. Because that's the problem with moving boxes. I say there's two kinds of jobs. There's moving boxes and there's brain work, right? Moving boxes, you never get the return on that. If you did that job and you slogged through those 100 lines, the next time you get a job like that, guess what? You're going to have to slog through it again. If you figure it out once, you know that for the rest of your life. In fact, you can even copy and paste that piece of code, right? Because the wonderful thing here is, notice what's happened. I have now clearly delineated the part that is copy-pastable or importable from a library from the part that absolutely requires user intervention. In other words, in my previous version of this, if I added a new term, I would have to make two changes. I'd have to add that term, and I'd have to remember every place where I needed those variables and like look for all of those places and go and do all this management. This idea is known as separating the data from the program. And it's the pattern that should be tickling in your brain when you look at a block of code like this. Because the pattern that I see as a programmer there is that you are putting data in the variable name. In other words, there are a couple of these things. They are called 1, 2, 3, 4, 5, and so on. When in fact, that should have been one variable. Right? So that should have been dx dt. Right? But that should have been a NumPy array containing all of these definitions. What that means is that all of this code now becomes that. And in fact, it means a very specific second thing as well. It also means that this line of code is the same every time you use it. And doesn't require that little maintenance, like that little bit of gardening. Oh yes, well I added the thing here, so now I have to add things over there, and I also have to remember to add things over here. This frees you up to spend more time thinking about what you're doing and less time thinking about programming.